So for the FDE cycle, the FDE stands for Fetch Decode and Execute cycle. The fetch part, the instructions or data are fetched from memory. They travel between main memory and the ALU uses buses. Well, between the main menu and the ALU, which is the arithmetic logic unit. The decode part, once the instruction or data has been fetched, they are translated, ready for execution. The execute part, finally instructions are carried out by the processor. So there's more information about the FDE cycle. So the fetch part, the PC holds address of the next instruction. The address is copied to the MAR. The contents of the address is copied to the MDR and CIR. The PC is incremented. For the decode part, the contents of the CIR is decoded into instructions which the control unit can interpret so the computer knows what to do. The execute part, the memory address collects any data needed to execute instruction, copied from CIR to the MDR, data found at address copied to MDR, then the data is used. Now there are multiple special registers and buses that the von Neumann architecture uses. You may remember some of them from F451. So the term register is the location in processor used for a particular purpose, temporarily stores data. So the registers that the von Neumann architecture uses is the main memory, which is RAM, so it stores everything that the processor is going to use, including the program, instructions, and the data needed to carry out the instruction. The control unit decides which instruction to execute next, then fetches it. It deciphers that instruction to work out what needs to be done to carry out the instruction. It has to tell the other part of the processor what they should do to execute that instruction. The PC, or program counter, contains the memory address to the next instruction to be executed, and then it is automatically incremented by 1 or so. So then the MAR, the memory address register, contains the memory address of the next piece of memory to be fetched. Then the MDR, it is the memory data register which holds the data that has been fetched from the memory. The CIR, or current instruction register, contains the instruction currently being executed, so the operand and operator of the current instruction. Now the accumulator, used for performing arithmetic functions, acts as a working area, so it's like adding stuff together and stuff like that. Then there's the index register. Register stores a number used to modify the address in the address field or data of an instruction. It is used in indexed addressing, and it allows access to a range of memory locations, such as, well, an example would be used to access an array. Interrupt register, which handles the interrupts. Then there's the buses, are just the control bus, address bus, and the memory/data bus. Now you may get a question on the jump instructions. So when it is executed, it changes the contents of the PC, so program counter. It changes the contents within the program counter, which is the address part of the instruction. It copies the address part of the instruction from the CIR, so the current instruction register, to the program counter, so it updates that value.